No audio? Okay. Can you hear me now? I think I got the mic going. Testing, 1, 2. Okay. The app seems to think I'm talking, so I'm going to go forward. Okay, so in this assignment, you start with an orders file. And people are saying that they can hear me, which is great. Okay, so let's consider an order. Let's say buy. Oh, you know what? Let me start over again. I want to make sure I get the syntax right here. So we have dates, buy or sell, symbol, and then number of shares. So let's say we have one order here that's 2008, 1, 2, and we're going to buy, let's say it's IBM, and 100 shares. And we may have more of these orders. Let's say eventually it ends in 2008, 12, 25, and we sell IBM 100. But we've got lots of other orders in there as well. Okay. Now, there's basically 3 data structures that I think you ought to use to build this project, and I hope they all fit on my piece of paper here. But let's start by talking about how you build them. So you need to know the start and end date for the data frame that you're going to build. And the way to do that is to scan your orders file. I'm going to get another color of pen here. So one thing to point out is in at least one of the example orders files, there are instances where the dates are out of order. So you need to, after you read in the orders file, sort on dates to make sure you've got them in the right order. Anyways, clearly the date of the first trade should be your start date, and the date of the last trade should be your end date. So we're going to build a data frame of prices. So let's call this DF prices. And use the regular get data method for reading in the prices. Question is, which symbols should you read in? So you need to also scan this orders file to find all the symbols. And let's put 1 or 2 more in there. Let's say we had a trade for Google as well, and maybe for GLD. Okay, so after we scan this orders file, we know we've got IBM, Google, GLD, and that's it for now. Okay, so we know start date, end date. We know our symbols. You can use get data to read that in. It's very important that you read trading days only. And we've gone over how to do that, so you know how to do that. So we read in our prices. We'll have a price for each trading day. Now, there's one additional thing I want you to add to this prices data frame, and it'll make sense a little bit later, but I want you to add one more column here called cash. So in this example, we'll have 4 columns of prices: IBM, Goog, gold, and cash. And these should be adjusted closing prices. That's very important. Make sure you use adjusted close. Okay, what's the adjusted close price for cash? Well, $1 is worth $1 every day, so this should be filled with ones all the way down. Okay, everybody follow me so far? Good. It takes about a minute before I see anything you say, so I don't know if you've answered me immediately. All right. These are our prices that we're going to work with. The next data frame you can initially create just by making a copy of this one. And let's call it DF Trades. And what this represents is changes in the number of shares on particular days of each of your assets. So again, we'll have columns IBM, Goog, gold, and cash. And this data frame represents changes. Okay, so here's how we populate it. We step by step go through our orders file, step by step. And each line, of course, represents a trade. So on this first date, let's assume that I'll draw a line over here. This first date is here, and we'll say this last date is here. On this date of our first trade, we gain 100 shares of IBM. Now we also lose some cash. So how much cash did we lose? Well, we take a look at what was the price of IBM this day. We look at how many shares we bought. Let's say the price, just for argument purposes, was $100. So it cost us $100 times 100 shares to buy IBM on that day. So we lost $10,000 in cash. Okay, so that's one trade on this particular day. We gained 100 shares of IBM and we lost $10,000 in cash. We step through all these other orders one by one as well. Let's suppose here we had a let's say we had a sell of 100 shares of Goog. So note that we had a sell before a buy. So on this particular date, we lost 100 shares of Goog, but we gained cash. So let me draw this line over here. So we lost 100 shares of Goog, and note we didn't hold any shares to begin with, so this means we're executing a short. Anyways, we gained some cash. How much cash did we gain? Well, again, you look at what was the price of Goog that day. You multiply it by the number of shares that you shorted. Let's say it was $20, just for argument's sake. So that means we gained $2,000 in cash on this day. Oh, one thing I didn't mention is that I'm assuming that all these values are initially filled with zeros. So we've got zeros all the way down. And then as we step through the orders, we put in non-zero elements there as they occur. Okay, let's skip down now to our final cell of IBM. So remember, we had bought IBM here, and it cost us cash. Let's say at this very last date that IBM had gone up. Let's say it's now $110. So we sell 100 shares of IBM, so we lose 100 shares here, but we gain some cash, and it's simply 100 times 110, so we gained $11,000. Whoops. Let me correct that. Plus 11,000. Okay. So we have so far two matrices. First is our prices matrix. Next is our trades matrix. And I'm going to pause for a second and see if anybody's got any questions that I can answer before I go to the next step. Okay, there are some questions that I'm going to answer a little bit later. There aren't any that are relevant right now to what I'm doing, so I'm not going to answer those questions at the moment. Okay, our next data frame, and I'm going to scoot this over a little bit to give myself some room. Make sure we can fit everything in there. Okay. This next one I'm going to call holdings. So this data frame represents on each particular day how much of each asset are you holding. So again, we've got IBM, Goog, which I'm just going to use G because I don't have enough room. We've got GLD and cash. And again, 4 columns here. And all we want here is to accumulate how many shares of each stock we hold and how much cash we hold. So again, we initially fill all these with zeros. One column is special, and that is the cash column. And what we want to put in this very first position is what was our starting value. Remember the starting value of our portfolio, plus how much cash we gained or lost on that first day. So this plus that goes into here. So this represents then on the first day how much cash we had after we bought that IBM stock. Let's suppose, for argument's sake, that our starting value was $1 million. Well, in this case, we'd then have $990,000 on that first day. Then for the rest of these columns, well, the way we step forward is we look at each row and we accumulate these numbers. So for IBM, on this first day, we get 100 shares. Google, there was nothing. Gold, there was nothing. Now we step to the next day. And what we do for each row here is we take the row above and we add to it this delta change. So on this second day, there was no change in anything. So we still have 100 shares of IBM. We still have 0 of Google, 0 of gold, and we still have $990,000. On this next day, we still have 100 shares of IBM, but now we have negative 100 shares of Google because we shorted it there. Still no GLD, but we gained $2,000 from shorting Google. So now we have 992K. We just continue step by step all the way to the last row. And on this last row, we will, so this remains 100 for IBM. There's no other IBM trades until this last row when we sell 100. So we end up with 0 IBM on that last day. We never exited Google, so we'll have negative 100 shares all the way to the end. We somewhere in here had a gold purchase. Let's say along here we bought 100 shares of gold. We never exited gold, so we'll keep that 100 to the end. And I'm not sure, we didn't do all the price calculations here, but let's say gold on this day cost $20, just for purposes of argument. So we would have lost 2,000, so we'd have a negative 2,000 here. So that would bring us back down to 990K cash. So 992 all the way until that date, and all the way to the end here, we have 990K of cash. Okay, any questions on that? Okay, no questions. I'll keep going. We're almost there. We're getting really close to the end. Okay, so we've got our orders file, we've got prices matrix, we've got trades, which are changes in holdings, and now we've got our accumulated holdings. Let's add now DF value. So this one represents what is the monetary value of each of our assets on each one of these days. So same columns. Four columns. And let me write on the bottom. So this represents the dollar value of each asset. Okay, how do you calculate that? Easy. It's just prices. It's just prices times holding. DF prices times DF holdings. All right, so on this day, let's say we've got 100 shares of IBM. Well, how much is that worth? It's worth 100 times whatever the price of IBM was on that day. So it's this one times this one, and that goes right here. And like that for every single value along the way. So now we'll have in each one of these cells for each day the value of each of those assets that we hold on that day. One more thing to do. Let's call this port val. This is a single column data frame. I guess I should call it DF port val. And all it is the sum of each row here. So it's just the sum of each row of DF val, and now we know for each day what the total value of our portfolio is. And that's it. That's how to do the first part of the project. Let me see if anybody's got some questions. Okay, I see some questions. Okay, I'll take them one by one. Okay, I got lost between the first and second line of the cash column of DF Holdings. Can you explain that once more? Okay. I got lost between the first and second line of DF Holdings. Okay, let's start with the first line. How much cash do we have on that very first day? We've got the starting value of our portfolio plus whatever cash we gained or lost with our first day of transactions. In this case, we lost $10,000 of cash because we bought stock. So we add together this delta, negative 10,000, plus the starting val, and that's the first line. What's the second line of DF Holdings? Well, on the second day, there were no transactions. So nothing changed in our holdings. We still have 100 shares of IBM, 0 of Goog, 0 of gold, and we've got the same amount of cash. So nothing changes in this matrix as we step forward unless there was a trade over here. So each row is the sum of the row above plus the current row in DF trades. So you just do a for loop. Actually, you can vectorize it, but it's easier to describe as a for loop. You do a for loop where you each row is equal to the row above plus the current row in DF trades. Okay, so I hope that answered that question. Okay, next question. In DF Holdings, when you step through each day, how do you handle multiple orders on the same day? Good question. So the way you handle that is you encode all those multiple trades in this single row in DF trades. So let's suppose that on this first day, we bought 100 shares of IBM and we bought 100 shares of Google. Then we'd end up having a 100 here. I'm not going to draw it in, but we'd have plus 100 IBM, plus 100 Google. But you need to additionally subtract whatever Google costs that day from this cash. So you encode multiple trades per day in the same row of DF trades. Then you don't have to, excuse me, you don't have to worry about it anymore because it's the rest of it is handled in holdings as you increment or decrement what happens each day. how to handle a buy and sell of the same stock on the same day. Same thing. So let me walk through this. Let's say here's our, well, I guess you can't see that, can you? You scoot everything back over. Let's say we had a buy of IBM and a sell of IBM on the same day. Well, as you step through your orders file, you encounter this buy. You update the so it's indexed by this date. So you go to this date in the DF trades data frame, and you make whatever updates you have to make according to what this transaction was. So we added 100 shares of IBM and subtracted whatever IBM cost. Now let's say immediately after that there was a sell IBM, and on the same day. So we go to that same row, and sell is minus 100 shares, so this would become 0. It's the same price, and we get that cash from selling, so this would become 0. So if we had, on the first day, a buy and a sell of IBM, same number of shares, this first row would become 0. The last part of that question is, do we need to address this in the project? Yes. The answer is yes. In the examples you provided, the value of portfolio goes down on the close of the second day. Value of the portfolio goes down on the close of the second. Are you talking about, let's see, let me read the question again. In the examples you provided, the value of portfolio goes down on close of the second day. Why in this case the cash gets deducted on the first day? Actually, the the value of the portfolio on the first day ends up always being exactly equal to the start value. Why is that? Well, our cash, we start with our start value in this initial cash row, but we bought some shares of IBM, so that cost us some cash, so we get 990K. But we bought 100 shares of IBM, and how much is the value of IBM? Well, it's $10,000. So when we come over here to this value, we would see that we've got 10K here. We've got 990K of cash. Well, 10K plus 990K is going to give us 1 million. So as a check, you should make sure that, I guess you couldn't quite see that. There we go. As a check, you should make sure that the first day of trading, that is always exactly equal to your start val. I missed the beginning. Is this being recorded? Yes. How do we handle the increase in position? Do we apply it in FIFO order? For example, I buy 100, 200, and sell 100 at different dates. Should we close the first 100? Doesn't matter. Can you explain how we had 0 share for IBM on the last day? Okay, well, we bought 100 on this first day, so in DF Holdings we have 100. There's no other IBM transactions until the last day, and remember we have this sell 100 shares of IBM on the last day. Well, if you subtract 100 from 100, you get 0. So that's how you get 0 shares on the last day. Okay, I'm going to get rid of these questions. Is this a margin account? Yes. How can we or should we, hold on, let me select that. How can we or should we normalize price data? You should not normalize price data. Okay, that's all the questions I see so far. I'm going to go on now to talk briefly about how to address the second part of the project, which is the leverage part. So here's how I would approach the leverage part of the project. I want you to add one more column over here. Let's just call it DF leverage. And you can, you could, if you like, say it might be more easy to add it to your value data frame. Doesn't matter, but just somewhere create a column that is DF leverage that is indexed by dates. And follow the equation on the wiki and just calculate the leverage for each day. Go through this data frame and check each day, is it greater than 2.0? And if it does exceed 2.0, let's say just for argument's sake that it exceeded 2.0 on the row that corresponds with this transaction. So that's the second row. So let's say it exceeds 2.0 on this date. All that I want you to do is go to the corresponding row in the orders file and nuke it, get rid of it. No transactions are allowed that cause you to exceed 2.0 leverage. Then wipe everything clean. Whoops, I guess you didn't see that. We nuked it. Wipe everything out, minus this order, recalculate everything, check again for leverage, and repeat this until this outer loop until you no longer have leverage exceeding 2.0. And that is it. That's how I would accomplish both parts of the project. There's one more question here I'll answer. I don't see any other new questions. But let me answer this remaining question. For project MC2-1, is there a way to calculate the Sharpe ratio by just using the dates of the orders and not calculate the daily portfolio values each day between orders? No. Okay, any other questions? I'll give it 30 more seconds just in case there's a lag. Okay, no new questions. I'm going to, oh, we got two. All right. The newly uploaded orders, orders 3 and orders leverage 2 have some problem. Okay. I guess you have to be more specific. Ask that question on Piazza unless you can provide more detail here. What if leverage exceeds 2.0 days after the order? So that's a very good question, and that often happens in real life. What happens in real life with your broker is your broker will go and sell some of your long positions or take cash out of your account to buy back your short positions so that your leverage goes below 2.0. That is, I think, a little bit too complex for this assignment. So all that I want you to do is check for leverage exceeding 2.0 on days that there are orders. So let's say on this day, leverage exceeded 2.0, but there was no corresponding order. Well, you don't need to do anything. I just want you to remove orders when there's when it corresponds with a day when the leverage exceeded 2.0. I will also say that our test cases are deliberately constructed so that leverage only exceeds 2.0 when an order occurs. Do you delete every transaction on the day leverage was exceeded? Yes. Follow up on leverage. So you delete from the orders data frame, then recalc. Yes. Well, let me put it this way. That's the way I would do it. There are other approaches to the whole project. So let me briefly outline another approach to the whole project. Another approach to the whole project that I think is wrong, but you certainly wouldn't be penalized for doing it this way, is you iterate, you create all this one day at a time. So you start on the start date, you look at the orders if there are any, and you update each of these for that corresponding row, and you check to see, was leverage exceeded that day. Then you go to the next day and update each of these sort of across like this. The reason I don't advise doing it that way is because it's slow. The method I described for you, once you, so you do have to iterate through the orders file to create this trades matrix. But everything else you can do just like that in a single line of pandas. And it's much, much faster than going row by row and calculating each row. Anyways, if you do it my way, you'll create the entire answer before you ever first check leverage. Then you'll go remove the order, the offending order, and calculate the whole thing over again. It turns out that that actually, although it seems somehow like a waste of energy to calculate everything, it turns out that it's actually faster to do it that way. Okay. For the newly uploaded CSV files, orders leverage 1 and orders leverage 2 are identical. Okay, thanks for that question. Let me ask you to please send an email to Utkarsh, and he's the TA who created those examples. Please send him an email stating exactly what you state there, and CC me. Okay, any other questions? All right, an important thing that we announced by email earlier today is that if you submit a solution before midnight on this upcoming Monday, we will practice grade it for you. So what that means is we'll run it through our auto grader, and you'll get a grade and comments, but it doesn't count. You can then take that information, correct your program, and we may even be able to grade it twice before the final overall project is due. Now, we're not necessarily going to be able to do this for all the projects, but because we've got some time now until the upcoming deadline, we want to go ahead and try and do it with this project. Okay, I'm going to go ahead and close up here. And right after I finish, I'm going to go check into Piazza and see if anybody has some additional questions. So post whatever additional questions you have there. Hope you found this valuable, and I will see you online. Bye-bye.